Assalamualaikum warahmatullahi wabarakatuh. Good morning or good afternoon, ladies and gentlemen. On behalf of our team, my name is Baiq Handayani. I would like to deliver a presentation with the title The Use of Very Small Business Scale Oven to Enhance the Quality of Ready-to-Eat Beef Jerky. These are our team: myself, Sri Widyastuti, Kertanegara, Asri, Hidayati, Wiharyani, Werdiningsih, Tri Isti Rahayu from University of Mataram. As introduction, in Indonesian concept, beef jerky is one of the preserved meat product principally made from beef, which is processed in a simple way using traditional equipment but still highly acceptable among Indonesian society. Based on USDA in 2004, beef jerky is processed from beef in thin slice of beef, is marinated in mix of spices, followed by heating into ready-to-eat beef jerky. Like other food, beef jerky, which are manufactured traditionally by small industry using a very simple techniques with minimal household equipment, offers some advantages such as easy technology, low operational costs, which then produce inexpensive foodstuff. Unfortunately, this kind of traditional process is usually done by workers with limited knowledge of hygiene and sanitation. Therefore, is not enough to eliminate pathogenic and microbial contamination. Oven drying for heating, or we know it as roasting, is one of methods used for ensuring the safety of jerky for human consumption. Usually, drying in an oven at temperature for 163 degrees Celsius for 10 minutes has been known to reduce population of some pathogenic microorganisms such as Escherichia coli and Listeria monocytogenes down to very low level, about 4 times 10 to the 2 colony forming unit per gram. Handayani et al. Proved that the use of laboratorium scale oven for roasting jerky offers a wide possibility of temperature adjustment, ensuring microbial pathogen elimination. However, the laboratorium scale oven is not applicable for very small business industry because of the high price. Oven that we use to control the some pathogenic microbia so we can have safe consumption of beef jerky. Usually we use the control oven. One of the control oven we have in the laboratorium is oven merek Memmer that able to produce good quality of ready-to-eat beef jerky. We have usaha kecil menengah or very small business. Commonly, they don't have the control oven, but they have the uncontrolled ovens. One of these are the oven merek Robhan, which have 12 racks. The control oven, since the control oven has possibility to produce very good quality of ready-to-eat beef jerky, and the other hand, the very small business scale oven such as Hawk or Robhan in this research has resulted in product with short shelf life based on Pratama 2013 and Handayani 2014. For those reasons, it is necessary to evaluate other type of oven such as Robhan 12 rack, which can be used for processing jerky at very small business scale production. So the objective of this research was to enhance the quality of ready-to-eat beef jerky using very small business oven. Materials and method. Material we used in this research were the lean meat of Balinese cattle purchased from butcher house in Banyumolek, West Lombok, West Nusa Tenggara, and mix of traditional spicy based on Handayani et al. In 2014. For the research method, jerky was processed as the previous method by Handayani et al. 2014 with the following step. Meat is trimmed to remove fat, sliced into pieces of 10 cm x 5 cm, then were frozen for about 6 hours to make easy at slicing step. Frozen meat pieces were thawed for 30 minutes under a running water while sliced using a meat slicer at a thickness of 0.4 cm. The meat pieces were weighed 500 grams, mixed with a mix of traditional spices, then were soaked in a solution containing 2.5% of liquid smoke for 3 hours at room temperature before sun drying. After drying under sunlight for 7 hours, raw dried jerky was then put in an oven and set at 135 degrees Celsius for 15 minutes. These are for the mammoth oven, and for the very small business scale oven, rope hand 12 rack at various roasting temperatures for 0, 5, 10, 15, and 20 minutes. From this slide, we see here in the right side, this is the flow chart of processing procedure to make ready-to-eat beef jerky. You can see here from some of this picture, this is the process of making beef jerky. As I said before, there is two kind of oven that we use. One of the mammoth, we conduct it for 15 minutes. This mammoth oven is the control oven, and the other one is rope hand 12 rack. This is the uncontrolled oven that always used by the very small business company. We use the oven for 0, 5, 10, 15, and 20 minutes of heating. We determine some parameters such as chemical quality, including relative humidity, activity of water, water content, protein content, and ash content. And for microbial quality, we determine total plate count, coliform, and fungi. The data we collected, we analyze using analysis of variance at a 5% significant level. The values showed significant differences were further analyzed using harness significant difference test for chemical and microbial data, and using a Duncan multiple range test, DMRT, for data for organic test, but we don't show it here in the presentation. Result and discussion. This table shows us the chemical quality of ready-to-eat beef jerky affected by heating using very small business oven. Like other drying equipments, ability of the hydrator oven is mainly affected on its ability to reduce humidity level inside the chamber. Chemical analysis was conducted to measure relative humidity inside the oven rope hand during the process. Table 1 shows that the roasting treatment or the heating treatment using the oven affected the relative humidity level inside the oven, water activity, water content, and protein content of the jerky. Table 1 shows 2 increased length of drying time correlated inversely to relative humidity. Without heating, the humidity level reached to 71%, which is significantly higher to other treatments such as 10, 15, 20 minutes of roasting time. Unfortunately, the relative humidity in the oven did not determine because it is not possible to put the relative humidity meter inside. The table 1 shows that humidity level of the oven correlated positive to water activity value of the jerky. Water activity value is indicator for the shelf life of the product. This is related to the water content. The higher the water activity, the higher the water content. Results show that the higher roasting temperature, the lower the activities of water value of the jerky, although it was not significantly different. The reduction of water activity values of jerky in line with the reduction of its water content. Besides that, protein content is also one of the important factors determining quality of beef jerky. Results shows that protein content of traditional jerky was relatively stable. Protein content of beef jerky roasted in the Robhan oven for 15 minutes was 26.41%, which did not significantly different than treated for 20 minutes. Generally, the lower the water in material, the higher the content of soluble component. Table 1 also presents that the roasting treatment did not affect significantly the ash content of the sample. Table 2 shows us the microbial quality of ready-to-eat beef jerky affected by heating using very small business oven, Robhan 12 rack. Table 2 shows us that all heating treatment in the very small business scale Robhan oven resulted the microbial content of beef jerky were less than 1 times 10 to the 3 colony forming unit per gram, which is relatively similar to those processed in the lab scale oven memory for 15 minutes. Table 2 shows that all oven-treated jerky bear low level of coliform count, less than 1 times 10 to the 1 colony forming unit per gram, and fungi less than 1 times to the 2 colony forming unit per gram. However, total microbes of untreated sample without heating or without roasting shows the highest microbial load, about 6.2 10 to the 5 colony forming unit per gram. This proves that drying under sunlight without followed by roasting in an oven resulted in beef jerky with microbial load still exceed the maximum limit set by the Indonesian national standard. The standard is 1 times 10 to the 5 colony forming unit per gram. That is the maximum level. So this table indicated that the beef jerky that produced by using the very small business oven can produce the safe consumption of ready-to-eat beef jerky. Conclusion: first, heating using very small business uncontrolled oven has significant effect on chemical quality, and all heating time treatment in the oven were able to reduce total microbes up to 2 log cycles. And furthermore, the total microbial such as coliform and fungi were undetected on agar of all treatment, therefore they were safe for consumption. Based on the qualities and supply parameters unreported, the best treatment was the roasting for 20 minutes at 135 degrees Celsius using the oven drop hand, resulted in the beef jerky with the quality similar to that produced by roasting in the laboratory scale oven member. This research was funded by Ministry of Education and Culture, Directorate General of Higher Education through National Priorities Research Master Plan for the Acceleration and Expansion of Indonesian Economic Development. Thank you very much.